The next type of graph that we're looking at is the histogram, and this is very similar to a bar graph. So each class of a frequency distribution gets a bar, and the height of each bar represents that class's frequency. And unlike bar graphs, consecutive bars of a histogram must touch. So we are going to be labeling the axis two different ways. The first is using the class midpoints, and these are numbers on the axis at the center of each bar. And for data that are integers, the class midpoints are the integers themselves. We're also going to be using class boundaries. So these are numbers on the axis that separate the classes without forming gaps. For data that are integers, we want to subtract 0.5 from each integer to get the lower boundary, and add 0.5 to each integer to get the upper boundary. Number 3 says construct a histogram for the data, label the axes, use the class midpoints for the x-axis. And then number 4 says construct a histogram for the data, label the axes, and use the class boundaries for the x-axis. So we are still using the same frequency distribution from number 1. So this is what the histogram will look like for number 3. Notice that the height of each bar is that class's frequency, and all of the bars touch. And we use the class midpoints for the x-axis. So that would be the integers themselves. And this is what the histogram looks like for number 4. So it's almost identical, except for we use the class boundaries for the x-axis. So instead of putting 66 here, we instead subtract 0.5 to get 65.5 and add 0.5 to get 66.5. So these are the edges of this bar, but the bar still does represent 66.